Hi everyone. So my topic today is about large-scale Plone migration for the University of Ghent in Flanders, Belgium. And we're kind of working on the migration to Plone 5.2 and basically trying to cover about what we are trying to do, what we have been doing, and what's missing. Just some words about my person. I'm using Python since 1993. Publishing since 1995, and Plone, yeah, almost since the earliest days of Plone. This year was basically a pretty busy year with Plone migrations. We've done 2 larger migrations to Plone 5.2 and Python 3, 7 smaller migrations to Plone 5.1, and perhaps planned some 4 other migrations, smaller migrations to 5.2, but the year is already coming to an end, so I'm not sure if we can get that. And at the moment, I'm basically working for the University of Ghent in Belgium as a contractor on their migration project. And yes, let's get started. So some facts about the University of Ghent in Flanders, Belgium. It's basically a university with 44,000 students. They have something like 9,000 staff members, something like 500 active editors, basically working on one large Plone installation. And the current state is that basically the current Plone installation at UGent is based on Plone 4.3. They have something over 80 add-ons. 80 add-ons. They are organized in something like 70 subsites, basically departments and then subsites per language, because they have to support Dutch and English as languages. They manage their content basically in standard folders and so on. There is no translation tool, so basically no Plone, app multilingual or Plone, what was it called, Lingua Plone involved. And the current migration team basically consists of 6 persons, 3 internal persons and 3 externals, and most of them are here. It's Bert, Fred van Dijk is working, Maurits is on the team, and Ivan and one at UGent. So a bit about the history of the UGent site. They started, I was told, in 2002 with basically something like a plain SOAP CMF site. Then I went to Plone 2.5 in 2007. Then all the steps to Plone 3.3, Plone 4.1, Plone 4.3 in 2015. Then there was a new theme added 2 years ago. And now they are on the move to Plone 5.2 and Python 3. So I think everyone has an idea about how Plone migrations work or fail to some degree. There are actually 3 migration approaches that you can do when you have an existing Plone site. The one that's mostly used is basically the old not the old, but the traditional in-place Plone migration that basically just takes your data as and creates a new Plone site based on the add-ons. But that wasn't applicable for the UGent site because too many old add-ons based on archetypes and so on. So there was basically not an approach here, as in most migration projects that we had in the past. So we're basically doing all export-import migrations. Then the other approach that is fully supported by the Plone people is the transmogrifier approach. I was on the project since April or May, I think. I was checking transmogrifier, but at that time it wasn't ready for Python 3, so I tried to give it a try by porting the stuff to Python 3, but I gave up after 2 days or so. But I think at the moment Casey Wainwright from 6 Feet Up is trying or is ready for the transmogrifier porting. Yeah. But at that time, as I said, I didn't have not much confidence in the transmogrifier. And so we are basically working on a custom migration, and that's basically a 3-phase project. I'll go into details later. It's basically just taking the content out of your existing site using collective.easyform. Then we're basically importing the data, the JSON files, into a migration database as interim migration database, and then importing the stuff into over Plone REST API into a fresh new Plone site. So here's a list of the existing. Plone add-ons used at UGent. Basically, the red ones are the packages maintained at UGent themselves, and then a lot of collective stuff. So you get an idea about the fun that we had to migrate or had to deal with it at some point. On the other hand, when you look at the content types used at UGent, it looks a bit much more friendly because they are only using the standard Plone types, and only for additional or 5 additional content types that are not part of the Plone core. That's basically Plone FormGen, you know that. Then there is a content type PHP defense for basically advertising PHP defenses, events, and so on. There's a vacancy module, library document type, and many of the types are in various ways extended by traditional archetype schema extenders. They have been using these technology pretty extensive, for good or bad. So the first thing that we did, or what I did at UGent, or together with the guys from the migration team, was basically analyzing and investigating the existing dependencies. So basically, the first was basically doing an inventory. What are the existing modules used in the site? What's their state regarding Python 3? So some add-ons are completely obsolete because they were based on archetypes. Other modules had been ported from archetypes to Dexterity. Some of them are still only Python 2 compliant. Others have been ported to Python 3. So basically, we just had to get an idea what's actually in the site and what would be replacement for that. So for some packages that were completely outdated, it was obvious that we basically had to drop them because they were completely obsolete, have been perhaps used in the past for some particular purpose, and some others were still no longer needed or basically replaced by functionality that already exists within Plone. And in some cases, we basically have to look for replacements or alternative packages. So the most prominent is basically that we had to decide, or had to see that we go from Plone FormGen to basically the equivalent collective.easyform. So what we basically did was basically in Confluence, we had basically a page just listing all the packages, short description with the source code, and then we had something like a column where basically try to figure out, is it Python 5 compatible, is it Python 3 compatible, dependencies, and so on, for just getting an idea about what we have and where we want to where we want to go. Because for something like 38 packages, you just need that written down in some reasonable way in order to keep track on the stuff that you are actually having to port. So basically, as a first step, just look at your stuff and get an idea what you have and what you can replace in which way. And then here's some packages in green, basically where we basically found replacements or found that, for example, the EA facet navigation. At the beginning of the project, that was red, but meanwhile, it has been ported to Python 3 and Plone 5, so it's green. So over time, some problems solved by themselves, others had been solved by us. So what we did next was basically starting with the target setup. Basically, we started with a fresh, empty Plone 5.2 build out, and then we added one add-on at a time that was basically we added all add-ons that were proven to be Plone 5.2 compatible and Python 3 compatible, and then basically incremented our build out for having a build out that basically in the first phase would be needed for doing all the content migrations, and the second phase for caring about the configurations and decorations and extra functionality. Because when you're basically doing a migration, the first thing is that you want your old content appear in the same way in your new site, and stuff like decorations like portlets that are perhaps second or third priority. So what did we do for exporting, for basically getting the data from the old site to the new site? In the first step, we have been using collective.easyform, which is also used by Transmogrifier for the exports. And it generates basically in our site something like 90,000 JSON files for the 90,000 con objects, about 55 GB of data, and the export basically took something like 90 minutes. all binary files like PDFs or files or videos are also exported within JSON. They are base64 encoded, and explains why the data is such huge. As said, we've been using collective.easyform. We did some minor extensions. I think the major extension was that we added support for exporting the Plone portlets, because JSONify basically did not care about portlets. So the JSON, you have basically one JSON file per content object, and the JSON file basically contains all the properties of the original object, basically the archetypes, schema-based properties, but also information about the workflow history, variable state, local roles, so basically all the stuff that's sitting persistent on the persistent object of each content object. In addition to that, we added some pre-computed values that we would later need for the migration. For example, like has this object portlets, other references, in order to be able to query the data later much faster. So as I said, one export take about 1.5 hours, and usually when the export script is supposed to work, there were some failures, you do this perhaps once, 2 or 3 times, and then you're basically having some export of your site, and can basically use this for the migration order for testing your migration. So in the next step, Transmogrify basically export all the JSON files to the file system, for good or bad. We have been using, or decided on using a migration database in order to be able to filter the data to be migrated, for example, by portal type. For example, when you want to test a particular migration on a particular fancy migration, for example, the migration from Plone FormGen to easyform, which is pretty complex, or the migration for collections, for topics to collections, you want to just run the migration on a particular subset, let's say only on a subfolder or on a particular content type. So for this case, we have been using ArangoDB. And anyone heard of ArangoDB before? Okay. Just a quick introduction to ArangoDB. Well, our first try was basically use a MongoDB, but that failed after 10 minutes or so, because MongoDB uses internally BSON as data format, and they have an internal limit of 16 megabyte. So a JSON file with a large image or so basically could not be imported in MongoDB. So I returned to MongoDB like in other projects. MongoDB is an open source database. It's basically a multi-model database. It supports storing key value stores, documents, so basically JSON documents. And it has a nice graph component on top of that, and this basically allows us to build graphs on top of JSON documents. That's very fancy. For example, when you want to architecture hierarchies or just relations between documents. And the nice thing that it provides a dedicated query language, AQL, Arango Query Language, which is basically a dedicated query language similar to SQL, not JSON, and it's very just to write down and to maintain and to understand. And importing all data, the 90,000 JSON files takes about 45 minutes, depending on the machine, hardware, and so on. And we could basically just dump all the data directly using some easy Python script into ArangoDB. Here's a short web overview over the web interface of ArangoDB. In this case, you see some query, for example, for doc in import. Then we can specify a filter clause. So in this case, we want to look for all documents in the folder /ploneportal/nl. And for documents of portal type event, and that will basically return a dictionary or an array with the path and the doc type, and this basically is the result. And all queries in the migration script later are basically based on AQL. Oops. Okay, so now we have the data in the database, and then you need some kind of import infrastructure. That's basically a standard Plone 3.7 and Plone 5 to build out, as mentioned, with the minimum number of add-ons that are basically tested and are needed for the content types. And in addition to that, as that the migration happens over Plone REST API. And in addition to that, we created a migration package that provides some additional functionality that isn't or wasn't provided by Plone REST API. For example, there is some special functionality for changing the paths in rejects fields to UIDs. This was coming from a recent project, so it isn't used. Or for setting marker interfaces, we have some support for setting the folder restrictions or the related items, permissions, and so on. So maybe some parts of these functionalities are already in Plone REST API. So it's basically just an addition to the functionality that we needed for migrating all the data and all configurations on the target system. So then there is a magic import script or migration script that basically takes the data from the database and then aggregates it and pulls it into our Plone REST API in the target system. And it's based on YAML configuration that allows us to configure the migration. On this side, you see something like that's the endpoint for the database. Then we have the endpoint for the Plone side. ID, then we can specify the policy package to be installed. Then we have some information about the languages used. And the most important part on this, on the right side, is basically that we can configure the content types that should be migrated. As that, in some cases, you want to test the migration of collections or the migration of form folders. Form folder is from Plone FormGen. So for this case, could basically just specify either the form folder or, for example, the collection, in case you would just want to work on this particular migration. In addition to that, you can specify a list of subsites or subpaths that are basically then taken for the migration. So when you know you have particular subsite containing, let's say, lots of collections and want to test just these collections with these in this folder, you can just then specify one path here and then only collection had here. And that simplifies testing a lot because you just create new configuration based on some old configuration and then makes the changes that you need. So what is actually happening during migration? It's basically a four-stage or four-phase approach. In the first phase, it's basically the migration script or the magic migration script. It's not that magic, it's pretty clean. It basically performs a migration check. It checks if the existing paths that are configured are actually existing in the database and so on. And then in the first step, it basically creates, over REST API, it creates a new Plone 5 site with a given number of extension profiles. So after the first phase, you get basically a new, fresh Plone 5 site with a given set of policy packages and extension packages. In phase 2 starts basically the migration of the content. The migration of content is split it into two parts. The first part is basically where we recreate the complete folder structure. So after, in phase 2, we basically ask ArangoDB, give me all folderish objects in order to reconstruct all folders or all folderish structures. And then we basically apply all the metadata, like title, description, and so on. So after phase 2, we basically get all the folders without the content. Also, folders are content, but the documents are then added in phase 2. That happens in phase 2. In the second one, basically then inject or populate the existing folder structure with the other documents like documents, FormGen, for news items, images, and so on. And in the phase 4, it's we perform some kind of fix-up operation or global action that we cannot perform in the phases before. One common issue is that we can assign UIDs so references to other objects like related items, only when the objects exist. So for example, when we would add a reference in phase 3 from one document to another document, and the reference document doesn't exist, it would basically create an error on the Plone REST API side. That's why we have to collect all reference in some way internally, and then basically apply all references for related items or for portlets in this last phase. That's also the reason why we assigned the portlets in the last phase, because then when we have portlets like collection portlets, which are using a reference, or if a collection uses a reference on some other folder, we can basically ensure that all data is here and all references can be applied properly. And then we apply some fix-up operation. For example, we always had the issue that after migration, the port catalog was completely inconsistent and broken in some way. And there is some fix-up or fix-up script for basically re-indexing all the stuff at the end. So focus on some special migrations. In this case, Plone FormGen to easyform. Plone FormGen historically based on Python 2 archetypes. Archetypes that will be gone. So we had to go to easyform. Easyform is a replacement. It's basically a clone based on Dexterity. It basically provides the same functionality, but based on Dexterity. The migration is a bit fancy because the export of a Plone form folder creates one JSON file for the form folder, and then one JSON file for each field, and one for each of the adapters. So we basically have something like 10 to 50 JSON files for one form folder and its fields. And what we basically do is basically transforming the JSON that we find here in these fields to XML. So we basically build, as that we collective Dexterity is based on the collective easyform is based on Dexterity, and you can express all the fields and the actions using a supermodel. And we basically use the XML representation for converting the JSON data to a schema for the fields and the actions. And that's pretty straightforward and works pretty well. So at the end, we basically just create a new easyform instance and then assign the two XML files for the fields and the supermodel and the actions as a supermodel to the instance. Another more complex migration topic is migration to collections. Basically the same as with form folders, except that the code is basically stolen from the Plone app content type migration code. It basically just picks up all JSON files for the criteria and then generates this magic query string for collections. And that's it basically for topics to collections. Another fun part was going from archetype schema extenders to behaviors. They are pretty widely used in the UGent side at the moment. The first thing we did was basically also make an inventory of all schema extenders used, how they are used, if they're used, still used, and we had to analyze what they're actually doing. And we had to check for Dexterity replacements, or had to check if we had to implement them on our own. Core issues here were basically that it was pretty painful in many cases for customizing existing behaviors, in particular the Plone ones, because, for example, the doubling core behavior is a mixture of 4 or 5 sub behaviors, and in some cases was necessary to subclass or monkey patch, so it was hairy to get it right. And some issues are still open. So migrating packages from Python 2 to Python 3. I think this was already covered by several talks over the last year by Philip and David. The most common problems were basically packages that were not based on archetypes that just need to be ported to Python 3. In most cases, we had to deal with UTF-8 versus Unicode-related code or broken code. In many cases, we had to deal with import fixes, and a common issue was always migrating the implements function to the implementer decorator, and I think also something for provides and provider. So it's basically mechanical work, but that wasn't hard. It was just had to be done. I personally myself didn't use 2223 or Modernizer for whatever reason. Perhaps I wanted to pain doing the migration myself. I don't know. And we didn't have the need for maintaining Python 3 compatibility. So we basically just created from master branch a dedicated Plone 5 Python 3 branch, and then fork, and then basically put the code, the Python 3 code, on a dedicated branch. In some packages we had test coverage, but in the main case I just tested stuff manually. We had to do some reimplementations. For example, there was a larger number of code sitting in portal skins. Portal skins is dead since ages, I think. And we basically replaced all this code using browser views. And in some cases, we had to re-implement whole packages that were written by UGent based on archetypes, like the subsite folder module, basically complete new package, porting the existing archetype schema and replace it with a Dexterity implementation. So we found some common problems in migration. In some cases, as said, the project started in 2002 or 4, I think, and we found some stuff like TIFF images stored as JPEG files with improper metadata. So this was fun when basically the migration script basically made an assumption that, okay, it's a JPEG, but it was a TIFF. Then Pillar was confused, doing some fancy or nested things. Then in many cases we had to deal with old values, for example in vocabularies where containing department names or department numbers, and these vocabularies change. For example, department goes away or gets a new name, so we had to deal with that and basically then replaced non-existing vocabulary values with new values. And all this stuff, adjusting your migration code, fixing bugs, is basically just a repetitive export-import cycle, and it always takes some time. And lessons learned, there's always one more bug in your migrations because you always miss something in your migration. And usually the bugs occur in the last 10% of migration after 1 day or so. And that can be painful. Let's talk about quality control. This has multiple aspects. One is basically consistency of your content and configurations. So basically we want that all your properties from your old archetypes content should be one-to-one exist in your new Dexterity content. That's basically, looking at the old content, looking at the new content, and then basically figure out if there's something missing. In some cases, we had systematic errors like different understanding what code or properties are supposed to do. Basically, lack of or a problem from the knowledge, transfer of the knowledge from the UGent people to myself, because I wasn't on the project for 1 or 2 months, and other people have been working on the project for 10 years and more. Unit testing was not very, didn't play a major role in the project because only some add-ons had tests. So quality control basically means that you have to go over all content, all subsites in some way, in a more or less systematic way, and do lots of manual testing. And in many cases, the typical works for me as a migrator. I see something and it works for me, but other co-workers come and see, okay, something is not working, so you have to deal with that. So again, to the old setup, as I said, 38 modules. And our current setup looks like this. That's still incomplete. But you see the number of add-ons is something about perhaps 20 or so. We also did some work on collective stuff, fixing some things, but as that these modules are basically what we have compared to that. So most of this stuff is basically either obsolete or some stuff must be ported. But in general, the setup is much smaller than it was. So what's the current status of the project? The content migration is almost complete, so we basically have a migration script that basically can import all the data from the old to the new site, except issues with migration errors. The next step was basically that the complete migration must be tested with one easy subsites and more complex subsites and so on, in order to get an idea if the migration is actually working. And then we need to bake the backend stuff together with the theme of UGent. It's based on Diazo, and we basically have to marry that and then see how that fits together. There are two open issues at the moment, or major two open issues. One is that membrane is used in one place for doing something with groups, and the other one is related to CAS authentication as a PAS plugin. I'm not involved with that, so I just noted both here. So coming to an end, what are the takeaways from my side as a backend developer or migrator? When we look at the export times, export from Plone to JSON takes something like 2 hours for 90,000 objects and 55 gigabyte of data. That's reasonably fast. You do that perhaps once a week or every other week. It doesn't matter. Importing the JSON files into ArungoDB, a decent NoSQL database, takes 45 minutes. That's also okay, because you do it also once per export. Then the import from ArungoDB with all objects or Plone REST API takes up to 2 days. And that's painfully slow and basically a pain in the somewhere. When you break that down into a single object migration, creating a single object, like, let's say like a document, takes something like between 1.5 and 2 seconds. And most of the time is basically spent when you create a new object in your folder. This should take something like 1.2 seconds or so, depending on your machine hardware and so on. And then you have some other operations for updating your workflow state and all this operations on top. So basically 2 seconds per object. There is no chance for doing any parallelization because CDB, you know, all the write conflicts. When you write from multiple writers to ZDB, you get these nasty write conflict errors. So my takeaway from that is basically that in 2019 or 2020, Plone and ZB are pretty slow, and I usually wouldn't consider that any more decent from the technology and point of view. So basically, we're talking about Plone as an enterprise CMS, but we have a horrible slow performance when it comes to mass import. So 90,000 objects is not mass data. Okay, any questions?
Yep.
We are currently doing some pretty similar migration from a Plone 4.3 side to a 5.2 on Python 3. We don't have as much add-ons, but pretty much the same amount of content. And the way we did it was just from an instance script on the 4.3 side and using the request library, just post it to the other side. Now, did you consider doing it this way, and you decided to do it exporting to JSON and the ArungoDB, and you find it's better, or you just decided to go this way?
We did that approach in former migrations. It was a pretty. It's basically the same approach.
Yeah.
You just have the export, the migration, and the import in one script. We wanted to decouple that stuff a bit, just for the reason that, as I said, I wanted to be able to perform partial imports or be able to query data directly. So I just wanted to have the old side somewhere, take the data out, and then work with database and so on. But the other project I was still working in the initial projects I mentioned in my About Me, and we're still doing some other upcoming migrations this way, because this migration script is very specific for the customer, and we basically, it exists and you can basically just adjust it. So from performance-wise, it will be the same, because you're just using requests, and so it doesn't make a difference.
Okay, thank you.
I'm only curious about the backend for this. Is normal this Zio server that's very slow, or do you use try Huey storage with Postgres or MySQL?
It's a standard Zio server, no RAID storage. I'm not sure if RAID storage would give us any performance improvements. I don't think so, because I think most of the performance during the create phase is basically, I think, indexing. Perhaps we could be using something like collective no indexing, but I think it's tied to archetypes. On the other hand, it wouldn't be a real, it wouldn't, well, let me explain it another way. When we have Plone as a CMS and a REST API, and other applications should be able to speak to Plone efficiently, independent if the backend is a migration script, or for example, some other exporter importer, or let's say another application. So basically, the overall performance for Plone when you create content should be reasonably faster than, let's say, 1.5 seconds. So I would expect a decent system to import this kind of data, let's say within 1 or 2 hours or 3 hours, depending on the hardware, but not 2 days. Particularly when you have errors during migration, and the error happens in the last phase, you're basically just wasting 2 days of work.
Andreas, I also have the question about the import time, because as you said, most of the time is spending about indexing and adjusting probably also the security permissions on it. Did you see an increase of the time that every write needs per second over the time,
No.
or is it
No.
becoming slower,
No.
or is it over the whole time the same speed?
Speed is basically constant, except for large content like images also. Just takes more time to commit, but for some content it usually takes the same amount of time. So there is no increasing inside time per object over time. And I didn't find security being an issue.
Two questions. One also about performance. The numbers you have are astonishing, very slow. The default migration is like times faster, much faster. Have you considered doing the patches that are done during the default migration concerning reindexing and stuff like that? You can patch all. Prevent. Oh, you can't, because you're creating new content.
I'm not aware of them.
So that's in the default migration. There we're patching away all kinds of expensive indexing and changing things. Also, if you create something with Plone API, no, that's REST API. Yes,
That's REST API.
You might want to look at the REST API code and add some patches there, because that seems incredibly slow.
No, but numbers are consistent. I spoke with a guy 2 days ago. They're doing the same, using a different migration script, and they basically had the same numbers with 36 hours for 85,000 objects. I don't recall who it was, but it's basically, Yeah.
So-
but numbers are basically consistent what we have
Okay.
figured out.
So I don't know, migrating a normal content object, you can migrate like 10 items per second in the default migration, I'd say. The other it would be interesting to investigate where you lose all the speed. The second thing is, since you put in all the work to migrate easyform to Plone FormGen, no, vice versa, much better. I've seen the code. Is there a plan to adapt that to put it into easyform so that users who are not using your migration approach can actually use it? That
The
would be
code
a
is
huge benefit for the community.
The code is actually released, at least an older version, so it's available. I'm not sure if I want to do any further with the stuff because it's just customer work. I'm not sure if I'm allowed to do such work based on the customer's budget, but in general, the migration code is there and should be very fairly easy to adopt that. For example, the University of Landau, they asked for the code and they're using a similar import migration, but just they export the stuff to ini files and then basically adopted the code for pathing the ini files instead of the JSON file. So it's pretty.
That's good for the University of Landau, but not really helpful for the community. I
I'm
think
aware
it
of
would
that,
be really good that the code is there and there would be a pull request or at least an issue referencing the code if you want to create a custom migration, not a custom, built-in migration from Plone FormGen to easyform. This is how you would do it. I don't know. It kind of seems obvious to me.
Yeah, it would be obvious. I think shouldn't be hard to do that, but could be also left to some community member because it's not the primary focus at the moment.
Andreas, I may have missed it, but have you considered disabling indexing or making it asynchronous with collective.indexing or something like that?
Actually not. I was thinking about last night about removing or clearing all indexes before the migration, or after design and then recreating the catalog at the end. That could be an option, but I haven't tried that. Perhaps with the next migration run next week or so.